This is an AS question on quadratic modelling. A company makes a particular type of children's toy. The annual profit made by the company is modelled by the equation P is equal to 100 minus 6.25 times by x minus 9 all squared, where P is the profit measured in thousands of pounds and X is the selling price of the toy in pounds. A sketch of P against X is shown in figure 1. There we go, here's the sketch to our right. Using the model, part A, explain why £15 is not a sensible selling price for the toy. So first thing that we need to do is to make the selling price, which is X, equal to 15. And we can use that to work out the profit and see if there's any issues there. So P is going to be equal to 100 minus 6.25 times by X, which is 15 minus 9 all squared. I can do that all on my calculator, and if I do that, so 100 minus 6.25 bracket 15 minus 9, which is 6, square that, I'll get minus or negative 125. Now remember that this is in thousands of pounds, and a negative profit is a loss. So this company is going to be making a loss of £125,000 if £15 is going to be the selling price of the toy. Not a good idea to be making a loss like that. So let's write that down in words. Okay, part B. Given that the company made an annual profit of more than £80,000, find, according to the model, the least possible selling price for the toy. Okay, so at this point it may be useful to show what's going on this graph here. So there's a couple of things to note. The profit needs to be more than 80,000. Now in our model, the profit is measured in thousands of pounds. So that means P will be 80 in our model, not 80,000. And we also need to find the least possible selling price for the toy. Now, if I were to sort of represent that on the graph here, let's say that a profit of 80,000 represents a value of P, which is about here. If I go across to my graph, I can see that I will get two values of X. Now, between these two values of X, I will get a profit greater than 80,000. I want to find out what these two critical values are and use the lower of the critical values, or the values of X, value of X that I get, to work out the minimum selling price that's going to just bump my profit over that 80,000 mark. So it's about solving an inequality here. So first thing, we've got P is equal to 80, but we want our profit needs to be more than that. So 100 minus 6.25 times by x minus 9 all squared needs to be more than 80,000. P is 80. So first step, let's take away 100 from both sides. I've got negative 6.25 x minus 9 squared is greater than negative 20. Now I'm going to divide both sides by negative 6.25, which immediately means that the sign will get reversed when you divide both sides or multiply both sides by a negative number. And if I do negative 20 divided by a negative 6.25, I'll get 3.2, or 16 over 5. Let's write that as 3.2. Then we will root both sides. So x minus 9 is less than, and because we're rooting, we need to consider the positive and negative square root. That's not a problem, because when I add 9 to both sides, I may in fact find that even with the negative square root, I end up with a positive answer. So let's see what happens and what two values of X we get. Right, so first of all, with the positive square root, change to a decimal, I'll get 10.78885, and so on. And then we'll look at what we get with the negative square root. So I'll just scroll back and stick a minus sign at the front, press the SD button, and I get 7.21115. 0.56, and so on. So these are like my two critical values. So this 7.2111 number is this lower one down here, and the 10.788854 is this upper value here. Now to get a profit of more than 80,000, the numbers need to be between these. So in other words, my upper value of x, so it needs to be less than that value to get 80,000. If it's equal to this value, I'll get equal to 80,000. If it's above that, I'll get less than 80,000. So it needs to be less than this upper value, and it needs to be greater than this lower critical value here. So my price needs to be just bumped up above this. Now this to the nearest penny would be £7.21, but that would give me a profit of 80,000. Yeah, because it's that lower value there. I want more than 80,000, so my selling price should be £7.22. You've got to round it up to the next penny so that your profit is above 80,000, not equal to 80,000. If I were to use £7.21, you can put the numbers in and check for yourself. You would get a profit which is either equal to or below 80,000. It needs to be more than 80,000. And part C, the company wishes to maximize its annual profit. State according to the model. First part of part C is asking us to find the maximum possible annual profit. Now there's no working involved in this. We can just look at the model and see what we're going to get. The maximum that this equation is going to be 100, because it's going to be 100 always subtracting a positive number. So you can't get any higher than 100. We'll never be subtracting a negative. This part here is always going to be positive, so we're always going to be subtracting a positive number, so it can never get any bigger than 100. It can get smaller than 100. So the maximum profit, even though it says P is 100, remember that stands for 100,000. And then for the second part of part C, the selling price of the toy that maximizes the annual profit. So again, we can just look at the model and work out the answers. I will get a value of 100 when I subtract nothing, 0. How am I going to subtract 0? When the bracket here is equal to 0, when x is 9, then this whole part of the expression here becomes 0. There's nothing to take away. I get the maximum. So that will be when x is 9. So the selling price of the toy then would be £9. And we can just state those values without actually doing any working, because it uses the word state here. Just write the answers down.